Uh, Good afternoon, everyone. Let's continue to discuss this paper, the firm's operational risk. The core question of this paper is asking, do firms' mandatory risk factor disclosure review operational vulnerabilities that predict future operating cost? So this paper answering this question using machine learning approach by training 64 models. So some work are very technical, but we can ignore those technical work and focus on the financial point of views. And this paper was published in forthcoming N and SOM. Because I checked this paper, it haven't been allowed to download yet. So first of all, this is the word crowd. When I input this paper, the highly frequency of this paper appear to be operational, which is the main issue. And the other is non-operational. And the risk, they have a 8 dimension of risk. And the training model, most frequent being used is a bird-based training model, and non-operational risk including another 7 type. So there's a risk type and disclosure, and model being transformed, and the others like financial terms. So another 7 type of the risk measure is marketing, international, finance, technology, management, legal, and so on. So this paper actually covered a diversity of dimension. So very smart paper when you do not have the facility to access the database. The most convenient way is to generate the data by yourself using machine learning to access the data from the financial report. So one motivation I picked this paper is the authors contribute a public data set. So they spend a lot of time to generate this data set, but generous researcher to share the data with everyone who are interested in using it to do a lot more. So researchers can use these risk scores to study other outcomes, not only their dependent variable cost of goods sold. So from the paper, you probably understand the authors are not finance-oriented researchers, right? Very technical, like operational researchers or production and so on. So they only use the cost of goods sold. This is a very original financial measures. So finance professor, finance researcher might use other type of measurement to measure like a cost of capital or the spread or stock volatility or firm value and so on. So this is a very high original, like a profit margin is a very original, outcome. So we can do a lot from the next. So think about that. What outcomes are you interested in doing in the future, if any possibility, because the data is free? And why should we know and care about these issues? So from managerial problem, disclosure risk in item 1A from 10K report. Have you ever assessed the SEC 10K report? That's a long, lengthy report. I assessed it like an apple, 1 page, 1 year per firm. I couldn't scroll down to the bottom. So you can see that that's a large number of the article, just 10K report. So the author only used item 1A, but even item 1A describe a lot of diversity risk in the report. So managerial problem is what kind of a risk was disclosure in item 1A. And this is a real information, or this is just boilerplate legal language. So from operational angle, operational risk is not an abstract one. It actually very real. Supply chain delay, quality failure, capacity constraint, or system outreach, logistic disruption can always increase the operational cost. So the paper just examined a very direct dimension, which is the operational cost, whether risk cost to cost increasing. So the paper asks whether mandatory disclosure help outsider to anticipate or predict the real operational consequences in the next year. So the intuition when we learn from the classroom is if a firm warned about operational disruption today, do we see higher costs tomorrow? We have to link both relationship very instant, very quick, because this disclosure may predict the risk in operational tomorrow. So input the data, large number of database, huge size. When running this data, you have to have a computer facility with a large space. And to create a dictionary count, like a finance risk have a lot of sentences related to finance. So your model have to train how many wording related to finance. For example, the paper say like 400 more sentences or term related to finance. That's a huge size. And like 200 more words or sentences related to accounting and so on. So you have to create a dictionary first by training the machine learning model. And pick one model that have the precise prediction or the less error. So this is the methodology. And then produce the output. So when you produce the output, you always approve the probability of the score, whether it's highly likely, most likely to have financial risk, or less likely. What's the percentage or what's the probability of that kind of risk being appear? So this is the input and output using machine learning model. So the main empirical claim is disclose operational risk predict higher future operational costs, especially when non-operational risk is also high. So this is the main conclusion from the robustness test and the endogeneity test, never change. So before we get into the paper, can you guys answer this? We probably don't need to use a Slido, but you can answer it in your mind. Using 1A, what would you expect 1A to be? A or B? Or C? Or D? A, raise your hand. B, raise your hand. C, raise your hand. Okay. D? Okay. We have a 90% of the participate answer B, which is correct. So 1K operational risk disclosure actually where we expect a warming signal that predict future cost. So you guys already present the case in more detail. So why 1A is the paper's key data source? So from 10K report, pick item 1A, and to extract the risk test, and to count the risk score, and to predict the future cost. This is the paper's logic. So SEC data provide 10K, and we can get the item 1A. And also extract the item 1A from the large sample, long period. And this is a very large sample, so it's very general, much broader than press release, which is very real samples. So this can be applied to the universe data. So it is mandatory and annual report, firm specific and much broader. We can see that the longer period and large size of sample. So it's better than a very small sample. Remember that we have some paper using machine learning, but they did not apply so large, maybe 5 years, 10 years. This is like a 20 years data. So I tried to assess SEC data. This is just one paragraph of the Apple in 2025. So this is a 10K report from SEC. You guys can assess it too. So I followed the item 1A, and it continues showing the risk factors. The first section is say the cyber security risk management. So your model might read these sentences repeatedly, and it might attribute this cyber security risk into technology, like that. And continue to retain K. Another one is like a gross margin, volatility gross margin, and it's saying that there have a downward pressure, volatility, and some wording may represent the operational risk in this paragraph. Continue to read the next item, 1A item, and here is showing the legal proceedings, Digital Market Act, and so on. So like this paragraph and this Apple 2025 may have legal risk factors and have operational risk factors and have technology factors. This is just one example, but human being will not do so much work. So you will input into the model using machine learning to categorize this risk for you. So the paper separates the risk into the core operational risk, including production systems risk, supply chain, and so on. So this is the core. But around the core, there is an external environment, including another 7 types of risk: accounting, finance, international, legal, management, marketing, and technology. Just I say, this is legal, this is operational. This is the technology and so on. So it categorize those report into different risk. So one firm may have 7, one firm may have 0, depending on whether your 1A, item 1A show those sentences or terms. So reading the materials, input, so training a lot of data, materials into the model. So it's a large size of materials have to be input. So the model have 64 distinct transformer model, including this type of model. Maybe we read like 1 or 2 papers using BERT, right? Remember that? We have one paper using machine learning, but they are using BERT model. So some researchers share their model in public. You can also apply to those. But different models have different prediction power. Some model prediction finance more accurately than the others. So here, there have some refined, like technology may using like a BERT model. Finance may using the other model different. So this is the methodology engine input, feed the data to the model, and pick the best one model that can have the precise prediction power using different type. So they compare and they refine, and finally get output. And so when you export the output, you will know which firm have what kind of risk measure and their probability scores and so on. So very important here, 10K disclosure actually is managers' private information. This have to be mentioned again and again. So you answering the questions, COO may disclose more when they get into the new job because it's heritage from the previous COO, not me. So this manages private information. I can choose to disclose higher risk, and I can choose to disclose lower risk in my tenure, late tenure. So this is the manager's private information. Manager can decide to disclose the high level risk measures or low level, depending whether the cash flow pressures is coming or whether they will produce lower margin, impact the stock price or valuation, and so on. So if they find that this impact is not good, they will adjust it. How much disclosure to be done? So this is a very different decision making from the CFO because the manager can decide. This is the manager's private information. He knows much more than the outsider. So when he discloses the risk, this information is asymmetric. It might impact the stock market or the valuations from the analyst. So all these sequences are quite important to decide. So risk factor text is not only in the language, it also reveals managers' private information about the future operating pressures. So this pressure can affect the margin and might infect the investors or analyst valuation and also impact the lender's borrowing cost. So many consequences will appear when you disclose the private information. So depending on the results that you can take. So this is very important from finance point of view. Disclosure is mandatory, but how much level, how much percentage, how much inside information, private information you would like to disclose is depending on the CFO. So even though the papers say we have A type of risk measures, but from finance framework, actually we focus on all this. The paper doesn't explain much more than finance professors say. So management, actually we count governance and the agency risk. Technology, actually, we move forward to cyber security and innovation. Legal, actually, we move to geographic risk and the regulatory risk and so on. So finance and accounting, auditing, reporting, and so on. Operational, supply chain, real activity, and operational cash flow risk will belong into marketing, customer, brand risk, demanding, and so on. So we can count all these events or all these measurements to reflect to the operational, reflection to finance accounting. For example, borrowing cost is one related to finance risk, right? And if you have a legal risk, then the lawsuit and so on, or tariff will be related. So this is the paper's ecosystem that you can apply to if you are interested in the future. So operational and non-operational risk, how to tell operational, very direct, supply chain, logistic, delivery, quality, human errors, disruption in core processing. This operational, very direct, the core engine. Around the core engine is external, so belong to the supporting system, finance, accounting, legal system, marketing, technology, and so on. So the paper separate into core risk versus non-operational risk, including all management type of risk. So operational risk directly affect production efficiency, and non-operational risk can amplify cost pressure by absorbing resources and managerial attention. So this is the very relative measurement. But actually, you guys can think about that. The papers actually is not like a management or manager or management orientated people as logic. When you see the table, they have a different identity, right? I also look at the table, spend a lot of time. Theoretical intuitions is risk disclosure is a signal because information asymmetry. Manager always know more about the risk than the outsider. So there have a disclosure signal. Item 1K communicate expected vulnerability and the risk management concern. The manager would like to communicate all this risk to outsider. So investors, it means the stakeholders, inferences is a supplier, analyst, the manager will infer all this to future cost pressure. They will change their target. So every time you see the SEC 10K report from 1K item 1A, you will see the stock price change instantly because analysts or the other institutional investor will announce or they will adjust their portfolio to sell some stock or buy some stock very quick. This inside information will be reflected very quick in the market. For example, like recently you will see like AI stock is not that kind of outgoing. So there have some potential risk. So you have to read the SEC 10K report from item 1A almost every time when they release instantly, because they reflect all this in the market. But the paper does not claim disclosure caused the cost mechanically. This paper is not good at the econometric methods. Maybe you can find that. Not difference in differences, no causality test, right? They only regress, simple regression, OLS, but never get the external shock to get a difference in differences, causality test. And even though they did the endogeneity IV test to expel the endogeneity concern, but their IVs pick the choice. I don't think the IV was chosen by a very good one, because usually IV should satisfy two requirements. One is inclusion, one is exclusion. But another requirement, actually this paper, IV doesn't match. So this paper doesn't claim disclosure cost mechanically. This is the reason, this is the result, not the cost. No causality. But it argued that disclosure contain information. Disclosure contain information about future operational cost. This is a T plus 1. And disclosure is at time T, well, affected future T plus 1's cost of capital, cost of goods sold, cost of goods sold. So because a difference in different models analysis is missing in this paper. So hypothesis 1 is positive, related to operational cost. Hypothesis 2 in this paper is interaction. When they included non-operational risk, then find the interaction. The higher non-operational risk will making the operational cost more stronger, positive related to each other. So it's 1 and 2 interaction. This is direct effect. So non-operational risk is the stress environment that can make the warning more costly. You have a direct effect, positively related, but you even have non-operational risk that will amplify this cost more significantly. So we can take a look at the coefficient later. Remind me, because the coefficient should be added together. 10K report, 9-step workflow. Read item 1A, clean the text, create the sentences related to each risk, and training the model, and adjust the 64 models, choose the best models for each risk measures, and then conclude or produce or export the score. All 10Ks, all firms, they have 16,000 more firms for each year during the 20 years, and get the average chunk and export the data set. Also large, very huge work. So sample and data source 10K item 1A, and combine with capital IQ compute state, because this is only risk measures, right? But they still have to control fixed effect. So those fixed effects came from compute state and capital IQ and merged together to get the final sample. Very attractive of this research is very broad coverage. And it's annually data, disclosure regularly, and public firm and scalable tax measures. And this is a very nice job. So this is a type of risk in 10K report, item 1A. And if you make a summation of those 7, you get another probability score of the non-operational risk. So dictionary counts and transformers probability, they use 2 kinds. Sometimes use the word count. Sometimes the paper using the probability. Let's take a look at the result. Machine learning measures how to build it. They also use the ChatGPT. So they generate 700 more risk mentioned sentences, so large. But these risk sentences related to a type of risk. Python to label each of the sentences and training the model using 64 model in total. But we never know whether the high model performance really means and prove the perfect real world classification. So this work, the paper doesn't do, even though say I picked the more precise and predictive power highest model in its paper, but he does not prove this is consistent with the results or the classification in the real world. So we can quit it or give one comment. The authors can do this. And the model selections using BERT-based cases, most of risk factor using this. And management uses DBERT technology using Roberta-based, different one. So it's just a training model and get the results, and we can get all these balanced sentences. So good machine learning performance is encouraging, but constructive validity is still required. So the paper using future cost of goods sold to validity their models precision, but it can do much more by other finance researchers because even though the paper using cost of goods sold to test whether the model is actually valid, the economic meaning, but we can do much more to solid this model and apply this model more broad. So how much risk languages appear in 10K? I just mentioned that the total word, 1K words, there have 1,330,000 words in total. But finance included 400 more, followed by management term. There have risk factors similar there, like 200 more, followed by technology. So finance related risks have the highest count number, word count numbers. So in total, there have 100 more word count. Can you imagine? This is belong to finance risk, but they already had 400 more words or a sentence. You have to train the model to recognize all these words. So they have a dictionary. You have a dictionary, all these words. So you have to let the model to read. And even though management, they have a 200 more wording or sentence. You have to give it to the model to let him tell that this is management risk, this is a technology risk, and this is operational risk. Okay, so this is the table. And from table 4A, this is a little messy, so I talked it earlier, and then we can take a look at the table later. Finance, if you look at the coefficient, actually this coefficient means probability score. So this means the probability. So that means they have the probability of the firm to appear to have finance risk. They have a 0.2 probability to have a legal risk. 0.177 probability to appear operational risk. Market risk is quite low. So this is the probability, predict the probability. You have finance risk. So they later using dummy because larger than 0.5 will be given a 1. Less than 0.5 will be given a 0. So all this will be given a 0 because it's less than 0.5. So using the absolute probability might be more useful in my personal point of view. So we can see the operational risk is only on average 0.177. So 1 means very likely, 0 means unlikely. This risk appear. So take a look at the real table 4A. Remember the numbers, right? Then we can take a look at the 4A. So 4A here, we can see finance, right? The probability. And the operational have the probability on average 0.177. The lowest probability to have a marketing risk is only 0.047. Very low. Technology very low. Management very low. But finance risk probability is relatively high. So this is the table 4A. And again, 6 have another variable summary statistic. I put here because each one uses different identity. I really can't stand for that. This is for dollars, operational cost. It's a dollar amount. Operational risk, non-operational risk is a probability. And this is a dummy. It is a summation of those 7 risks. But all this belong to probability. So operational cost is a dollar sign. Okay, so this cost of goods sold, and this is a probability for operational risk is 0.19. Summation of those 7 risks is 0.787. Control for the fixed effect. I need to mention R&D ratio because R&D ratio here is the R&D expenditure divided by total assets, and this is relatively high. Normally, it's like a 3% in usual. I did a lot of American data is like a 3% to 5% only. But these data sets appear to have a 22%, extremely high. And unbelievable, they have a negative. The same way cost of goods sold have a negative. So the data have some noise without cleaning still. So this is a dummy, this is the wording, and this is the dollar side, this is the probability, and this is the ratio. Okay, so they put it in one table but different identity. So when you read the table, table 6, remember to tell this is different identity. So if we separate the risk from low to high into Q1 to Q4, from low risk operational risk to high operational risk, we can see the operational cost is increasing. From the univariate test, we can see this is increasing already. And using multivariate regression model to compare with the univariate test, the results are consistent. So using operational risk, T, and interaction T at T, and to predict the cost of goods sold, operational cost, T plus 1. Control for the fixed effect, yield effect, and error term. So here is the result we can see. So highly operational risk always positively related to operational cost, the next term. The full model in model 4 control for all fixed effect and interaction and error terms and so on. It conclude positively related to each other. And the interaction was even bigger on coefficient, 0.247. Here is 0.298. So amplify the impact. If you already had operational risk positively related to each other, no matter what your non-operational risk, but higher risk is coefficients larger, right? Higher risk actually amplify this cost in another coefficient. So this is the baseline. We can add another additional impact for this impact. So in total, we should combine 2 coefficients together. One thing I have curiosity is the R square. I never believe a regression could conclude the 96% of explanation power. Usually they have some collinearity or something just unexplained. The paper should check whether the R square is so high with some potential collinearity. The paper does not explain. We can check the full model in model 4 because all have the same explanation power. Did you feel that it's acceptable? Because this doesn't control. When you control more, you can increase your explanation power, but you did not control. You have the same explanation power. Isn't it? Well, so I give the question mark about this. And also, the same thing, robustness test, you see, all the explanation power are the same, never change. I can't imagine this. They control different all different, but the explanation part are the same. Observation are same, appear to be the same one. See that? 0.963, and observation usually you will drop something or add something because you have different fixed effect, right? So this is SiC4 code, and this is interaction. You control different, but your observation always consistent, and R square always consistent, and even though the coefficient doesn't change, positive and amplified more significant. This is even the same as the previous one. 29A. Did you see that? 29A, but they control different. Control variable are totally different. So I do think that the robustness check have some minor errors. I can't believe that the model's different. Observation always keep the same. Coefficient never change, especially model 2. And the explanation part is always same. But this is not a finance paper, actually. It's like a strategy finance paper or innovation finance paper. Okay, so this is the result from the coefficient. They have a significant positive related to high cost. And even though this is negative, but interaction amplify the impact largely. So the coefficient is even larger than 247. So risk disclosure is economically informative, not just legal formality. So this is a very important conclusion. They have economic informative and not just the legal formality. So finally, we can see that if high risk associated with the non-operational risk, you will get the higher operational cost in the next term. But low operational risk might lower the operational cost in the next term. So this is the interaction means. So I think this is a very good visual image that we can apply to. We usually interaction in every paper, but very seldom that we can describe in more detail about using visual map. So can you guys answer this? The positive interaction between both means what? You can vote here. Okay, maybe next, maybe later. Okay, so the interaction means what? A, B, C, D. If your answer is A, raise your hand. B, raise your hand. C, raise your hand. D, raise your hand. Right, correct. 100% saying B. That's the correct answer. That means that you totally understand so far. And there have the robustness check about the not just the probability, using counts, word counts, and fixed effect, different than the endogeneity IV. Okay, so result remain, doesn't change. we can take a look at the IV. Because the IV they're using industrial yield, not just an individual firm, industrial average risk leverage using industrial on average level. So instrumented by industrial yield average risk leverage. So not just instrument using industrial average risk leverage, that's a risk measure, to instrument the operational risk, so using industrial average. But this is the second stage. We can see that the result doesn't change. Positive significantly related to operational cost the next term, right? But these IV choice have some concern. I need to addressing that this exclusion restriction is a hard assumption to match so far, but you're using industrial average, this could affect the operational risk. But you have to exclude that this does not impact the operational costs the next term. But exclusion criteria is hard to match so far. Also, maybe this is not perfect IV, but these people are using this IV so far to conclude the endogeneity concern does not change, does not exist. Okay, so you can accept it so far, but remember that the causal interpretation should be cautious because it's not endogeneity concern totally without any concern. And also there have a difference in different shock doesn't examine. So there are some comments, okay. So advantage is this is really a good beginning to read a financial report and to generate different kind of risk measures, a type of measures that researcher can do more following the paper and using their data. So this is a huge work, very contributed and very valuable. But still something have to using validity to make sure that the risk measures they generate are very accurate. So we need some paper to prove the data are very precise and can apply to a universe of fields in the future. Okay, so this still need the validity in the future. And another one is the difference in differences and the reverse regression might exist. So the shock is lacking, and the industrial shock is hard to separate sometimes. And potential improvement is using this shock, SEC 2020, to separate the before and the after to see whether causality test exists. So this is another strictly requirement, if any chance that you can do to prove that the endogeneity and omitted shock will not affect the results. So here is another interesting outcome for researchers. If you're interested, you have a lot of dependent variable. This is not independent. You can do independent from the A type of risk, but this is dependent variable. Which one are you interested in? If you are doing the next project using their data, which dimension, which outcome will interest you? Hmm? You can think about that because I have curiosity. I will ask you later. Which one? First questions, I have the last two slides that you guys can answer. Which extension, then where we like to go? Which extension would be most convincing for improving this paper? Okay, I will see your results. And after that, I have another one. You can think about that. I will let you go very quick. Eight, 10, 11. Yeah, perfect. That's the critic of this paper, the most valuable one to enhance this paper. And another, if any chance to do a similar paper using this data, I just ask you, what dependent variables would you exempt? Pick one. Open questions. This paper doing cost of goods sold. We have some critique on that. And what's your idea? If you do it again, which dimension will you use? You can pick one turn, two turns, three turns. All are acceptable. Long terms. Yeah, that's another paper using their data, but doing the same way, but another paper, long term. Let's see how many paper we can generate from this paper. Free data set for all of you. Operational cost is the same one. They're using cost of goods sold. Are you mentioning the same one? Okay. You examine stocks return volatility. Firm value, Tobin skew. That's a good one volatile. Because of high risk, high volatility, high risk may discount firm value. Stock return, we have a 1, 2, 3, 4. 3 to 4 papers, new papers generated. Can you guys define the operational cost again? It's the same one as this paper? Cost of goods sold, or you measure differently? We have a stock return volatility, firm value paper. We have a long-term paper. What else? Yeah, when you answer operating cost, can you let us know how to measure that? Because its definition might be different. Cost of capital is similar to long-term paper. Return on assets is profitability. Yeah, it's similar to firm value, but using accounting measures too. We generate like 6, 7 paper, and we can generate another inventory holding. This is supply chain paper. We have operational loss severity paper. Yeah. Okay. So in general, we have management paper, finance paper, we have a capital market paper, we have a banking paper too. Okay, using all the term U type. Okay, so very good beginning. Very good beginning that we have different papers generated, presented. Okay, I just want to scroll down the result. Like this. Okay, I cannot scroll down there. But at the bottom is the long term. Okay, it's the long term. So cost of capital and stock volatility. Just see. Okay, nice. Okay, so you guys can continue to do more if you are interested in this kind of questions. Okay, and any other questions so far? Okay, so today we review the papers using different measurement from machine learning model. And the paper actually construct a very precise and very broad universe data applied to listed firms. Very useful using SEC 10K report from item 1A. So there have a lot of steps to generate this data, and we can capture the image from the word crowd using this risk measurement. And today's class will end here. Any other questions?